All right. So we are going to talk about Unit 2. And Unit 2 we should all be good with because guess what Unit 2 is all about? It's all about quadratics. Okay. So hopefully you learned in IM2 last year because a lot of you guys had Mr. Gaitan or Ms. Hernandez or Ms. Flores, and they're all great teachers. So all of you should know how to factor. um, you guys should know how to factor. That's actually what we're going to do in this unit. Please take this time to do the warm-up. You are going to multiply these numbers together for parts 1A and 1B, and then parts 2A and 2B, you're going to factor. All right, and then 3 and 4, that's not very relevant to quadratics, but still stuff you can do. You're going to name 3 numbers between 2 and 3. So all in all, I'm going to give you guys about 5 minutes to complete the warm-up, and then we're going to check back in. All right? Any questions before we begin? Okay, you guys can get started. Okay. So let's take a look and see what we were supposed to come up with. 1A, we are multiplying and simplifying. We are going to distribute the number on the outside. So that means we're multiplying 5x times x and 5x and negative 3. What is the final answer going to equal for this problem? Raising your hand so I can call on you. Roman, yes. 5x squared minus 15x is correct. This is the final answer. Let's move on to the next one. Now we are doing the same but with a different number. 3x squared and 2x plus 7. Abby, go ahead. Excellent. So 6x cubed plus 21x squared. All right, are we good so far? So we're just multiplying these numbers together using distributive property. I see some of you guys use like an area model. That also works. Okay. Let's go to the next part. So now we're factoring. If we're factoring, we're looking for the greatest common factor. Okay. Greatest common factor. That's GCF. Now, in case you don't know what a factor is a number that fits, that like you can divide from whatever you're given. So what number can we divide from 5 and from 15? 3 doesn't go into 5. 5 goes into 5, 5 goes into 15. But what else do they share in common? They have an x in common. So we are dividing 5x from each term. So that means if we divide by 5x, 5x squared divided by 5x will give you x. Right? It's like we're working backwards now. And then if we take 5x out from 15x, that's going to give us negative 3. And this is what our solution will look like. And this is actually what we started with earlier, remember? In part 1a. We started with this, and then we got 5x squared minus 15x. So now we're working backwards. We're dividing out the terms. If we look at this one, what is the greatest common factor between 6x to the third and 21x squared? What number goes into 6 that goes into 21? That would be 3. We take a 3 out. And then how many x's can I take out? We can take 2 x's out. Very good. So we can take 2 x's out. Our GCF is 3x squared, and that'll leave us with 2x plus, what is this? 2x plus 7. Okay? And that is the final answer. Are there any questions on 1 and 2? Great. Then let's jump to numbers 3 and 4. Name 3 numbers between 2 and 3. So imagine that there's a number line, and we have 2 right here and 3 right here. Then what are 3 numbers that I can come up with between 2 and 3? Give me one of them. Raising your hand. What's one of them? Isabel. 2.1. What's another number that I can... Go ahead, Maddie. 2.2. One other number. Vanessa. 2.3. What if I came up with something like 2.9372871? Does that work? It works. It's a big number. Well, I guess not big, but it's a lot of numbers, but it's still less than 3 and greater than 2, so that works. Okay. Really, there are an infinite set of numbers between 2 and 3, even though it might not seem like it. Let's go even smaller. Now let's go between 1.1 and 1.2. So same thing, number line. Imagine there's a number line. Here's 1.1. Here's 1.2. What are 3 numbers that I can come up with between 1.1 and 1.2? Go ahead and give me one of them. Elise. 1.01 would be like less than 1.1. Let's think of another one. 1.11. Where were the? I think that's over here. 1.16. It's another number. Diana, take a guess. Wild guess. Yes, 1.12. What if I chose 1.14717689932? Would that work? Yeah. Why? Because it's less than 1.2, but it's greater than 1.1. 1.01 is too small because it's 1.0. 1.0 would be less than 1.1. Okay. Anyway, so same idea. There are actually an infinite amount of numbers between 1.1 and 1.2 because you can just keep adding numbers after 1.1 until you get a new number, basically. Okay. All right. So that concludes the warm up. Let's go ahead and skip the guess my number activity. We're not going to be doing that. So you can cross it out like that. Just exit out. And we're going to go straight to the guided notes. Okay. Guided notes, interval notation. Okay, so we're going to talk about 2 different kinds of intervals. We're going to talk about bounded intervals and unbounded intervals. All right, and for the notation, we are going to be looking both at inequality notation and then what's called interval notation, which is when we use parentheses and brackets. So basically what this is, or what we're doing here, is we're using inequalities or parentheses slash brackets to show or to tell you what the set of numbers is. Like, what numbers are we including in this graph? So for example, look at the first one, graph, we'll call it number 1. I know it's hard to tell, but we have a point at which value of x? At 1. And then this whatever number line is, it goes from 1 all the way to what? It goes from 1 all the way to 5. Is this showing us numbers less than 1? Like, is that part of the graph that we have? No. What about numbers that are greater than 5? Are those part of the graph? No. What's it showing? It's showing us numbers between what 2 numbers? 1 and 5. So basically anything you want between 1 and 5. So the inequality, how we're going to express this is, first off, we're going to think back to IM1. And we're going to talk about inequalities. Any inequality, or sorry, any graph that has a closed circle means that it has an inequality that is or equal to. So for something to have a closed circle, that means it's or equal to. Now in this case, our bounds are the following. We're starting at 1, and it's any number greater than 1, greater than or equal to 1, right? 1 is, this right here says less than. When we say 1 is less than, what we're saying is numbers greater than 1. So it's kind of like the alternate argument. So we're saying 1 is less than, and then x is any number that we want. But this number has to be between 1 and what? And 5. So x cannot be greater than 5. So as an inequality, we would represent this as the following. 1 is less than or equal to x, and x is less than or equal to 5. Think about it like this. You are a number x, and you're trapped between 1 and 5. That's why x is in the middle. It's right in between 1 and 5. So x could be any number you want as long as it's between 1 and 5. Okay? And the notation would be the following. We have a limit at 1, so that's like our first bound. It's at 1. And we have an upper bound at 5. So we start at 1, comma, we go all the way to 5. And because we have closed circles, we are going to have these brackets that are square brackets. Okay? You use square brackets anytime you have a closed circle or like an actual bound. We can't go past 5. So we should probably write that somewhere. Let's see. You guys have some space up here, yeah? Let's do the following. So closed circle. You get these inequalities, the ones that are or equal to, paired up with these brackets. And then open circles, you have the inequalities without the line underneath. So like just the inequality greater than or less than, no line underneath, no, or equal to. And then we're going to represent those bounds with a parenthesis. Okay. So we'll kind of refer to this as we fill out the rest. But just write that down for reference so that we can refer to these later on. Okay. All right, are you guys done writing these down? Perfect. So let's move on then to the second example. And you'll notice that the graph is basically the same, but we are changing the kind of circle that we have. So we still have a circle at 1 and a circle at 5, but these are no longer closed circles. Now these are open circles. So we're still going to use the numbers 1 and 5. And yes, x is still in between 1 and 5, but now our inequalities are not going to have that line underneath. So now we're saying, yeah, x is greater than 1 and x is less than 5, but it's not or equal to. Right? So x is just greater than. It's not greater than or equal to 1. And now x is less than 5, but not less than or equal to 5. And the reason why, once again, is because we have these closed circles, or open circles, I mean. For notation, we still have our bounds at 1 and 5. But once again, because of our open circles, the way that we express it won't be with a bracket, but actually with parentheses. And the reason why we have these parentheses, we usually use them when it's an unbounded interval, meaning there is no like solid limit. So think about what it means for x to be greater than 1. If x is greater than 1, x cannot equal 1. So x would have to always be like 1.0000, like a bunch of zeros, and then 1. But it's still bigger than 1. It's never going to equal exactly 1. So it's never going to touch those numbers if you think about it. And that's why we use like the parentheses instead of the brackets. Brackets means like, yes, you can be exactly equal to that number. Okay, this one is closed circle with open circle. So we still have 1, we still have 5, we still have x in between them. But now x is greater than or equal to 1. X is less than 5. Just less than. Not less than or equal to, because of our closed and open circle. How do you think we're going to express the bracket notation? I'm going to have 1 and 5. But what kind of bracket does 1 get? Does 1 get a square bracket, or does 1 get a parenthesis? 1 gets a bracket. 5 gets a what? Parenthesis. Let's say we switch this around. Now we have an open circle first, closed circle after, which means 1 is less than x is less than or equal to 5. I have 1 and 5. 1 will get what? Parenthesis, while 5 gets a bracket. Okay, now you'll notice that these are all examples of bounded intervals, meaning you have a set of numbers like bounds. X is trapped in between these two numbers. For the next part, we're looking at unbounded intervals. So like you just go on forever in one direction, or you go on forever in the other direction. And we'll talk about what that looks like. Are you guys done writing this down? Okay. Let's look at this one now. So for this graph, we're starting at 5, and we are going forever to the right. What kind of numbers can we expect to be to the right of 5? Are these numbers going to be greater than 5 or less than 5? Greater than 5. Give me a number that is greater than 5 that we could find like over there. 6, 7. Okay. Maybe like 100, right? Or like a million. All these numbers would be over here on this side. So inequality-wise, we're saying, okay, x is greater than 5, but because of our closed circle, x isn't just greater than 5. X is greater than or what? Or equal to 5. Your notation, we're going to start at 5. This is your lower bound. What is your upper bound? Infinity. We're going forever into the positive values. So forever into the positive values means infinity. Now, is infinity a number? If it's like infinity is a term. Infinity means like a bunch of numbers, but it's not one singular number. So infinity is unbounded, which means that infinity always gets a parenthesis. 5 gets a bracket because it's a closed circle. Okay? We look at the next one. It's the same exact thing, except instead of a closed circle, now we have an open circle. So x will simply be greater than 5, not greater than or equal to 5. And our bounds, although we still have 5 and infinity, both of them will now get parentheses. Because 5 is an open circle. So 5 therefore gets a parenthesis. All right, I'm going to ask one of you guys to give me the next one. How do I write the inequality for the next one? We're still starting at 5, but we're not going to the positive anymore. Now we're going the other way. So x is now what? Is x greater than or is x less than? X is less than. So x is now less than 5. Is it less than or is it less than or equal to? Less than or equal to. So we kind of have these, this sign right here, less than or equal to. And then is my lower bound still 5? If I'm coming in from negative infinity, now my lower bound is negative infinity. And why is it negative infinity? Well, it's going forever to the left. So we're going towards negative infinity. So we're coming in from negative infinity, and then our upper bound is now 5. So this will be parenthesis, this will be bracket. Okay. And if we just change this around, we still have the same thing, but we're just changing the brackets. So now we will have parentheses, and we no longer have or equal to for the last graph. And the reason why is because we have an open circle. Okay. All right, how are we feeling so far? So we're looking at graphs where there is only sort of like just one single thing on the graph. Now let's see what happens when we have two graphs on the same number line. So we're going to look at compound unbounded intervals. Okay. Just for reference, this graph, this right here is 1 and this right here is 5. So let's see if you guys can come up with the first inequality. How do I express the first inequality, this first part of the graph? This is starting at 1 and going to the left. How would I show that with an inequality? X is less than 1. What about the other side? Now the one that is starting at 5 and going to the right. How do I express that part of the graph? X is greater than 5. So we're just forgetting one thing in here, and that is the following. If x is less than 1, we also have this other potential part of the graph, which is x greater than 5. We're going to kind of put them aside and say, okay, with this word or, we're saying we could have two different graphs. X is less than 1 or x is greater than 5 shows us both of these graphs together. So the word or, we're going to be using a lot. We're also going to be using the word and, but we'll talk about that later. So that's the inequality for the interval notation. If it's x less than 1, that means it's going towards negative infinity. So we're coming in from negative infinity, stopping at 1. And then we are starting with 5 and going toward positive infinity. But this keyword or, instead of writing the word or, we're going to use a mathematical symbol for or, which is a U. It looks like that. Yes. That's right. It is. Thank you. Okay, so as a notation, we're going to have negative infinity, comma 1, or 5, comma infinity. See if you guys can come up with the next one on your own. I'm going to give you the solution to it in just a second. Yep. Okay, you guys should be able to come up with all of these on your own, because the only thing that's changing is the symbol and the bracket, right? Depending on what's open, what's closed. So let me give you 3 minutes or 2 minutes, I should say, to finish up the rest of these graphs. 2, 3, and 4. Okay. Give it a try. Muy bien. No, pues para eso están para eso los senté juntos. ¿Qué pasó? ¿Pero qué pasó? Hazle nomás refresh, hazle refresh nomás. Ah. Okay, when you're ready, you can check your work. Yeah, take the pass. Okay, take about 20 seconds to finish writing, and then we're gonna move on. All right. So let me give you guys your next task, and this is probably gonna put us until our break. This should take us about 20 minutes or so. So your next task, you're gonna work on the following team problems as a team, and I am gonna give each of you guys, like as a group, a participation quiz. Meaning, you're gonna have the following things to do. Everyone needs to work on the same problem at the same time. All right. So I'm gonna walk around, and if I notice that maybe David is on problem A and Bowman is on problem C, like Bowman's way ahead, taking points off. But if you're working together and you're all on task, then you get points for that. Make sure that your conversations are strictly about math. I don't want to hear anything about matcha or other kind of stuff. Yeah, or that type of stuff. Yeah, I don't want to hear that. That's going to be points off, right? You want to be working on the math, talking about the math, and make sure you guys are all working together, please. All right. So you can go ahead and begin, and if you have any questions, call us over for help. All right. You're gonna get a grade for participating, though. All right. Questions? Yes. Question. Oh, yeah. I'll fix that. Okay. You guys can start.